Hi guys, here's the lesson on arithmetic sequences, just in case you were absent or you need a refresh on what we did during class. So an arithmetic sequence is a sequence in which each term after the first is found by adding a constant, which is called the common difference. So this right here, your common difference, is whatever you are adding and subtracting every single time. So if you're adding and subtracting the same number every single time, that is called an arithmetic sequence. For sequences, we have specific notations. You'll see A's with subscripts. So A1 is your first term, A2 is your second term, A3 is your third term, AN we call the nth term, so that's any term for the sequence. This N right here, the subscript, always corresponds to the term number. So if you notice for A1, your subscript is 1 since it's the term number. So for the first example, we're finding the next terms of a sequence. It's pretty simple. You need to start by figuring out your common difference, so what you're adding or subtracting every single time. So if we're going from -8 to -6 to -4, we are adding 2 every single time. So our common difference for this is 2. We would like to find the next 4 terms. So your next term after -4 is going to be -2. Add 2, you get 0. Add 2, you get 2. And then add 2, you get 4. So these are the next 4 terms of the sequence. For the practice problems, you're doing the same thing. So you need to start by figuring out what your common difference is. So to get from 16.5 to 16.3 to 16.1, what's happening is it's going down, so you are subtracting. So your common difference is negative, and you're subtracting 0.2 every time. So if we were to continue the sequence, our next term would be 15.9, 15.7, 15.5, and then finally 15.3 for the 4th term. For number 2, you're going from 3 to 15 to 27. Your common difference for this is 12 because you're adding 12 every time. So 27 plus 12 is 39, plus 12 is 51, plus 12 is 63, and finally plus 12 is 75. So that's finding the next terms for your sequence. Now, let's say I wanted to find any term for the sequence. So I wanted to find the 50th term. It wouldn't make any sense at all to list all 50 terms. So instead, what we can do is we can use the explicit formula. The explicit formula is used to find any term. So before we even start using the explicit formula, let's define all the pieces of the formula. So AN is the nth term. D is your common difference. A1 is our first term. And N represents the term number. Okay, so for the second example, we're going to write the explicit formula, which will allow us to find any term for the sequence. So to be able to do that, since we're trying to find it for the nth term, N is going to stay as a variable, but we need to know 2 things. We need to know our first term, and we need to know our common difference. So our first term is very easy to spot. It's -8. Our common difference, well, you need to figure out what's happening with the sequence. This is the same sequence as the first example. Our common difference is 2. So I can take those 2 things and replace it into our explicit formula. So I have AN equals my first term, which is -8, plus D, which is 2, times N minus 1. From here, we can simplify it further, so we can distribute the 2 into the parenthesis. So that gives us -8 plus 2n minus 2. Combine your like terms, and that gives you -10 plus 2n. And then that is your explicit formula for the nth term of the sequence. So if I wanted to find any term, I would take that term number and plug it in for n. Okay, so letter B, is 2001 a number in the sequence? Explain. So we need to analyze the sequence. If you look at your sequence up here, we're going from -8 to -6 to -4. Our common difference is 2, which means all of the numbers after that you're adding 2. So if you notice, your pattern results in all even numbers. Well, if you look at the question, it says, is 2001 a number in the sequence? No, because it is an odd number. So your answer for this is no, because 2001 is an odd number. And every term in the sequence is even. That's just to get you to think about your sequences, think about the pattern, and see if you can apply it further. All right. The table shows typical costs for a construction company to rent a crane for 1, 2, 3, or 4 months. Write an explicit formula to model the sequence. So we're going to answer that first before we continue. So again, to write an explicit formula, we need 2 things. We need our first term and our common difference. Well, our first term is for the first month, which is 75,000. And then our common difference, we need to figure out what the pattern is. So to get from 75,000 to 90,000 to 105,000 to 120,000, you are adding 15,000 every single time. So now I can write the formula for the sequence. So I have AN equals my first term, which is 75,000, plus my common difference, which is 15,000, times n minus 1. Once again, I can go ahead and distribute. So that gives me 75,000 plus 15,000 times n minus 15,000. I can go ahead and combine my like terms. So 75,000 minus 15,000 is 60,000 plus 15,000 n. Okay, so this formula will allow us to find any term for the sequence. Now, going on, assuming that the arithmetic sequence continues, how much would it cost to rent a crane for 1.5 years? Now, be very, very careful with this. So we're looking for the cost after 1.5 years. Now, if you look at the sequence, your sequence over here, your terms, are in months. So we need to start by changing 1.5 years to months. Well, 1 year is 12 months, so 1.5 years is going to equal 18 months. Since 12 months is 1 year, half a year is 6 months, so that gives you 18 months. So what we're looking for is we are actually looking for the 18th term. Be careful, do not plug in 1.5 down here, because your term number should always be a whole number. So we're looking for the 18th term. So that means I can take 18 and plug it in for n. When you do that, it should come out to $330,000. Okay, another way that you can do this is you can actually continue the table until you get to the 18th month and then figure it out that way. But that takes a lot more work. It's going to take longer, but you will still get the same answer. You will still get the $33,000 or $300,000. For the practice problems back here, we want to find the 18th term and the 54th term for the sequence. So the n represents the term number. So if I'm trying to find the 18th term, I am taking 18 and plugging it in for n. So I have 6.25 minus 0.5 times 18 gives me negative 2.75. And then for the 54th term, I'm doing the same thing. except now I am plugging in 54 for n. So again, n represents that term number, so whatever term you're trying to find, that is what you are plugging in for n, and that gives us negative 20.75. I'm not going to do number 4, that you can try on your own. For number 5, you're supposed to write an explicit formula. This right here is a typo. Write an explicit formula for the nth term of the arithmetic sequence. So you need two things. You need your first term, which is 18, your common difference, so to get from 18.25 to 32 to 39, we are adding 7. So we're writing the formula, so that's an equals my first term plus d times n minus 1, distributes. That gives you an equals 18 plus 7n minus 7. I can combine like terms, so 18 minus 7 is 11 plus 7n. So this formula for the sequence will allow us to find any term for the sequence just by plugging in that term number in for n. And again, number 6 you can go ahead and try on your own. Alright, hope that helps you. Have a great day.